You've probably heard that digital data is stored and represented in binary, which is made up of just ones and zeros. You might have also wondered, why? Why not use all the digits from 0 through 9? It might seem that would be a lot easier to just use them all. To motivate this, we're going to use an espionage example. Let's pretend that you're a spy and you want to communicate or transmit information to another spy. You don't want to blow your cover, and so you can't be seen together. The system of communication you have decided to use is to put a light in your window that can be seen from the street. Your fellow spy can simply walk past your window and see if the light is on or off. We're using this example not only because it's illustrative, but because actual spies have used this communication method. Drug dealers have also been known to use similar techniques, but we don't know anything about that. With this method, you can communicate just two messages. Of course, you would have to agree in advance what the messages mean. Perhaps when the light is on, it means go ahead with the assassination, and off means don't go ahead with the assassination, just chill. Or perhaps when the light is on, it means I have drugs for sale. Oh wait, never mind. One problem with this system is that you can only communicate two different messages, or for reasons that will become clearer, two different values. What if you need to convey more possible values? Well, you might be inclined to hook the light bulb up to a dimmer, and then you use various degrees of brightness to communicate different values. For example, we could convey 4 different values with 4 different brightness settings: completely off, dim, medium bright, and fully on. You can probably already see the inherent problem with this system. With 4 different brightness levels, how confident are you that the other spy can tell the difference between dim and medium bright? What if it's a rainy day or a really bright day? Instead, a better approach is to throw away the dimmer and put 2 lights in the window. With 2 lights, we can convey 4 possible values, corresponding to off-off, off-on, on-off, and on-on. If we put 3 lights in the window, there would be 8 different values. If we have k lights, then there would be 2 to the k different values. The base is 2 because there are 2 states for each light, on or off. So why is digital information stored and represented with binary? Because it's really easy to determine if something is off or on. If we were to build computers to use 10 digits instead of 2, it'd be like using 10 different levels of brightness. That would require digital electronics and storage devices to be much more sensitive. Let's say we want to represent about 1,000 different values. With binary, we would need 10 different lights. With decimal, we would only need 3 lights. Sure, we need more lights with binary, but not that many more lights. More importantly, each light is simpler, less expensive to produce, and can be read more accurately. Binary information is really just like a whole bunch of light switches that are either off or on. When they are off, it corresponds to 0, and when they're on, it corresponds to 1. This representation, off is 0 and on is 1, is actually pervasive throughout our society, and it has been adopted in many ways you may not have ever noticed. For example, light or power switches often use 0 and 1 to indicate whether it is off or on. And we can use the same button to turn a device on or off. They actually use a logo that shows a 1 and a 0 combined together. You've probably seen that logo many times and not realized that it's a 1 and a 0. If you have a hard time remembering which number, 0 or 1, is on, remember that in English, the number 1 has the word on right inside of it. In computer memory, digital information is literally stored in tiny circuits that are either off or on. They aren't little tiny light switches, but their function is surprisingly similar. Digital information can also be stored on a wide variety of physical media. On hard drives and floppy disks, the off-on information is stored in small areas that are either magnetized or demagnetized. On USB drives and SD cards, the information is stored as electrical charges that are kind of like static electricity. On CDs and DVDs and Blu-rays, the off-on information is stored as little pits on the surface of the disk. In all of these physical media, there's a clear way to indicate 2 different values. It is this characteristic, the ability to easily distinguish between 2 distinct values, which is why binary is an excellent choice to represent and store digital information.